Welcome to 15-Minute Discourse. Are you ready to have your mind blown? Today, we're diving deep into programmable matter.
Which most people know as
Claytronics.
Claytronics, right?
And you've sent us some fascinating sources on this. We've got academic papers, we've got patents.
Even military reports. It's really cool. It's a diverse set of information on this topic.
Let's start with the basics. What is Claytronics? How would you explain this to someone who's never heard of this before?
So Claytronics is basically like making matter, but making it out of tiny robots. And this differs from typical modular robotics because it's not about building a single complex machine. It's about creating a new type of matter that can just software be programmed. And so Goldstein talks about this in one of his papers, and he uses this word pario.
Pario.
Yeah, it's like a physical, real-world version of computer graphics.
So we're talking about
Like holograms?
like a hologram, but I can touch it.
Yeah, you can touch it, exactly.
So that's Claytronics, and it's made out of these little robots called catoms.
Yeah.
And so tell me a little bit more about these catoms. I'm looking at this programmable matter final report, and these things are incredible. They have their own CPU. They can communicate. They even have a tiny display.
Yeah, so each one of these tiny robots has all of these capabilities packed in. And if we look at Nyan's thesis and Goldstein's paper, we see that one of the biggest challenges is just powering them and getting them to move and stick together.
Yeah, it's got to be pretty hard if these things are super tiny.
Well, the goal is to get them down to a micrometer scale, smaller than a human hair.
Really?
Yeah.
Wow. So how do you even begin to power something that small?
Well, there are different approaches, but one of the ideas that they talk about is wireless power transfer.
Interesting. So we're beaming energy to these things? Wow. Okay, so we've got these catoms that can move, they can communicate, they can stick together. How do we get them to actually form a 3D object? How do we go from a swarm of catoms to a table?
So there's this concept called decentralized control, where instead of having a central brain controlling every single catum, they follow local rules based on their interactions with their neighbors.
Oh, so it's kind of like ant colony. So each individual ant isn't very smart, but together they can build these incredible structures.
Exactly, and that's the same principle that's at work here with Claytronics.
That's so cool. And it makes sense because if you have millions or billions of these tiny robots, you can't possibly program each one individually.
Exactly. It just wouldn't be feasible.
So we need them to be able to figure things out on their own based on their local environment.
That's right.
I'm starting to understand how this all comes together, but I have to ask, how do we actually manufacture these catoms? I mean, we're talking about microscopic robots with their own CPUs and displays. That seems pretty far out there.
It is challenging, but one of the techniques that they're looking at is microfabrication.
Okay.
Just like how we make computer chips today.
Like photolithography and stuff?
Yeah, exactly. They're using techniques like that to create these incredibly small, complex robots.
It's amazing how much technology has advanced. I mean, we're talking about making robots that are smaller than a human hair.
I know, it's incredible.
And it's not just about the size, it's about the complexity. The fact that these things can communicate and move.
It really is mind-boggling.
But I'm guessing it's not going to be cheap to produce millions of these catoms, each with its own tiny silicon chip.
You're absolutely right. The Goldstein paper talks about the economic challenges of this. Building a macro-scale prototype with larger catoms is one thing.
Okay.
But if we want to create this, synthetic reality that we've been talking about,
where objects can just morph and reshape themselves.
we need to get those catoms down to the microscopic level.
Right.
And that's going to be a very costly endeavor.
So we're talking about millions, maybe even billions of these tiny robots, each with their own little brain and the ability to move and communicate. That's going to require a massive investment in research and development.
It will, but think about the possibilities. If we can crack this, we could have self-healing materials, buildings that adapt to changing needs,
Okay.
medical implants that respond to your body in real time.
Now that's where it gets really exciting for me.
Yeah.
It's not just about cool shape-shifting robots. It's about a fundamental shift in how we interact with the physical world.
Right. It's about blurring the lines between the digital and the physical.
Exactly.
Okay.
We've only just scratched the surface here, but this is already blowing my mind.
Yeah, there's definitely a lot more to discuss. We've touched on some of the challenges of controlling these millions of microscopic robots.
Right, and I think it's important to really dive into those challenges.
Absolutely.
Because we're not just talking about programming a few robots here.
Yeah.
We're talking about potentially billions of these tiny units all interacting with each other.
Right. It's a whole new level of complexity.
So how do researchers even begin to approach this problem?
Yeah.
I mean, traditional motion planning techniques just won't cut it at this scale.
No, you're absolutely right. So one of the areas that they're looking at is bio-inspired algorithms.
Okay, so we're talking about taking inspiration from nature.
Exactly.
Yeah.
Like, you know how ant colonies or swarms of birds can achieve this incredible coordinated behavior?
Right, and they don't have like a single leader telling them what to do.
Exactly. It's all decentralized.
So we're trying to apply those same principles to Claytronics.
That's the idea. We can learn a lot from how nature solves these kinds of problems.
That's fascinating. It's like we're looking to nature's blueprints to guide our technological innovation.
Yeah, it's a really cool approach.
But even if we can figure out how to control these catoms, there's still the issue of powering them.
Right.
I mean, we're talking about robots that are smaller than a human hair. How do you even power something that small?
Well, traditional batteries are definitely out of the question. They're just too bulky. So researchers are exploring things like wireless power transfer.
Oh, so like we're beaming energy to these tiny robots.
Exactly. Like think inductive charging,
Whoa.
where you have a magnetic field that transfers energy to a device without any physical contact,
So we could potentially have these catoms just swimming in a sea of energy.
essentially.
That's incredible. But then there's still the problem of communication. How do all these catoms talk to each other and coordinate their actions, especially at such a small scale?
Yeah, that's another major challenge. Traditional methods of communication like radio waves become less effective at the microscopic level.
So we need to find new ways for these tiny robots to communicate.
We do.
It's like we're creating an entirely new language for them to speak,
Yeah, it's a really interesting problem.
and a really complex one.
Absolutely.
It's mind-boggling to think about all the different aspects that need to come together to make Claytronics a reality.
It is, but that's what makes it such an exciting field.
Definitely. But with all this complexity comes risk, right? What happens if these catoms start malfunctioning?
Right. That's a valid concern.
I mean, I've seen those sci-fi movies where nanobots run amok and it doesn't end well.
Yeah, the gray goo scenario.
Exactly. Is
Yeah.
that a realistic concern with Claytronics?
It's something that researchers are definitely taking seriously.
Okay.
And they're working on developing safety mechanisms to prevent that kind of thing from happening.
So, like, what kind of safety mechanisms?
Well, one idea is to have kill switches that can be activated if the catoms start behaving erratically.
Okay, so like an emergency shutoff? That makes sense. But even with those safeguards, there are still broader ethical considerations to think about.
Absolutely.
I mean, this technology has the potential to be incredibly disruptive,
It does.
and we need to be prepared for the societal impact.
Right. Like, for example, one of the biggest concerns is job displacement.
Yeah, as Claytronics matures, it could automate a lot of tasks that are currently done by humans.
That's right. And that could lead to significant job losses in certain industries.
So we need to think about how to mitigate those impacts
We do.
and make sure that the benefits of Claytronics are shared equitably.
Exactly. It's not just about the technology itself. It's about how we use it and how we ensure that it benefits everyone.
Well said. And beyond job displacement, there are also concerns about privacy and security.
Right. Because imagine a world where objects can constantly reshape themselves and gather information about their surroundings.
It's like something out of a sci-fi novel.
Yeah, it's both exciting and a little bit scary.
Definitely. It raises questions about data collection and surveillance. Could Claytronics be used to create a world where our every move is tracked and monitored?
It's a possibility that we need to be aware of.
So we need to think about privacy regulations and security protocols to make sure that this technology is used responsibly.
Right. We need to be proactive in addressing these concerns.
It's a lot to think about, but it's important that we have these conversations now
It is.
as the technology is being developed.
We need to be thinking about the ethical implications from the very beginning.
I completely agree. So we've talked a lot about the potential of Claytronics and the challenges that come with it, but where does the research stand right now?
Well, there's a lot of exciting work being done in labs around the world.
Okay, give me some examples. What are some of the cutting-edge developments that you're following?
Well, one area that's particularly promising is modular robotics.
Modular robotics. Can you remind me what that is again?
Sure. It's basically about creating robots that are made up of many smaller identical units that can connect and disconnect from each other.
Oh, so it's like building blocks for robots.
You can think of it that way.
So you could have a robot that can reconfigure itself into different shapes and perform different tasks.
That's right. It allows for incredible flexibility and adaptability.
So it's like a stepping stone towards the ultimate vision of Claytronics, where matter itself becomes programmable.
Yeah, you could say that. It's helping us to develop the fundamental building blocks and control systems that we'll need for true programmable matter.
That's really interesting. What are some of the specific projects that are pushing the boundaries of modular robotics?
Well, one project that I find really fascinating is the work being done at MIT with these M blocks.
M blocks, what are those?
They're these little cube-shaped robots
Okay.
that can jump, climb over each other, and even roll around.
Wait, jumping cubes. That sounds like something out of my childhood.
I know, right? But they're actually incredibly sophisticated.
Really?
Yeah, they use internal magnets to control their movement and can self-assemble into different configurations.
So they're like little robotic building blocks that can move and assemble themselves autonomously.
Exactly. And while they're not at the microscopic scale of Claytronics yet,
Okay.
they're demonstrating the potential for creating robots that can adapt and reconfigure themselves on the fly.
That's incredible.
Yeah.
And what about the research on Claytronics itself?
Yeah.
Are there any groups making significant progress towards creating those microscopic catoms?
Yeah, absolutely. The Carnegie Mellon University group that actually coined the term Claytronics is still very active in this field.
Okay.
And they've made significant strides in developing the basic building blocks for these catoms.
Like the tiny actuators and sensors.
Exactly. And the communication systems.
So we're getting closer to that vision of microscopic robots that can reshape matter at the atomic level.
We're still in the early stages, but the progress is definitely encouraging.
That's exciting to hear. And it's not just limited to robotics, right?
No.
There's also research on reconfigurable materials.
Right. Materials that can change their shape and properties on demand.
So we're talking about materials that can go from hard to soft, or from transparent to opaque.
Exactly. And these materials could have applications in all sorts of areas like soft robotics, adaptive architecture, even self-healing clothing.
Okay, now that's really cool. It's like the physical world is becoming as malleable and programmable as the digital world.
It is. And that's what makes this field so exciting.
It's like we're witnessing the birth of a whole new era of material science.
Yeah, it's a really transformative time.
And it's not just material science, it's robotics, computer science, all these different disciplines coming together
Absolutely. It's a truly interdisciplinary effort.
to create this vision of programmable matter.
And it's a vision that has the potential to revolutionize countless aspects of our lives.
It's mind-blowing to think about all the possibilities.
It is, but it's also important to remember that we have a responsibility to guide this technology in a direction that benefits all of humanity.
Right. We need to make sure that it's used ethically and sustainably.
Absolutely. We need to be mindful of the potential downsides as well.
Well said. So before we wrap up this discussion, I'd love to hear your thoughts on the future of Claytronics.
Okay.
What are some of the most exciting possibilities that you see on the horizon?
Well, I think one of the most exciting areas is healthcare.
Healthcare. Okay, how so?
Well, imagine a world where we can create personalized medicine that's tailored to each individual's unique needs.
So we're talking about like targeted drug delivery systems.
Exactly. Where you can deliver medication precisely to the affected area, minimizing side effects and maximizing effectiveness.
Wow. And what about smart implants?
Yes, implants that can monitor your health in real time and even adjust their function to respond to changes in your body.
It's like having a personal doctor inside your own body.
Yeah, essentially. It's
Yeah.
a really powerful vision.
It is. But I imagine there's still a lot of challenges to overcome before we get there.
Oh, absolutely. Like,
Right.
for example, biocompatibility is a major hurdle.
Right. We need to make sure that these microscopic robots can safely interact with the human body.
Exactly. And that's a big area of research right now.
So we're talking about developing materials and designs that are not only functional, but also safe for use inside the human body.
Exactly. It's a delicate balance.
It's amazing to think that we're trying to create robots that are so small that they can operate at the cellular level.
I know, it's incredible.
And it's not just about healthcare. Claytronics has the potential to revolutionize so many other industries as well.
It does. Manufacturing, construction, art, and design, the possibilities are endless.
It's really exciting to think about all the ways that this technology could change our world.
It is. It's a field that's full of promise and potential.
But it also requires careful consideration and responsible development.
Absolutely. We need to make sure that we're using this technology for good.
Well said. This has been an incredible discussion, and I'm so grateful for your insights.
It's my pleasure. I've enjoyed it.
I'm truly inspired by the work that's being done in this field,
Me too. It's really cutting edge stuff.
and it makes me hopeful for the future.
Me too. I think Claytronics has the potential to make the world a better place.
I agree. So to our listeners, if you're as fascinated by programmable matter as we are, We encourage you to dive deeper into this topic.
Yeah, there's a wealth of information out there.
And we'd love to hear your thoughts. What applications of Claytronics excite you the most?
Leave a comment below and let us know.
And don't forget to like and subscribe to 15-Minute Discourse for more fascinating deep dives into the world of science and technology.
Thanks for listening.